Dear students, today we will be discussing on crawling and cogging in the case of three-phase induction motor. First of all, we will start with crawling. In the case of three-phase induction motor, there is a tendency for the motor to run at a speed 1/7 of synchronous speed, and that too a stable operation. It will not be able to pick up the speed to the normal speed that is near to the synchronous speed ns. This phenomenon is called crawling. We will now analyze the reason for the crawling. We had already seen in a waveform there can be harmonic contents, that is the signals which will be having the frequencies other than the fundamental frequency, and the frequencies can be the integral multiple of the fundamental frequency. So in the case of induction motor 2, the air gap flux can be having harmonic. It can be caused by the magnetic saturation because of the slot arrangement for stator and rotor, and can be because of the winding arrangement, and it can also be caused by the inequalities in the air gap length. Even when the magnetization current is a sinusoidal one, because of the air gap, the winding arrangement, the slot arrangement and all, the magnetic flux that is caused need not be a sinusoidal one. That means the waveform will be having the harmonic content, and we can say it will be having space harmonics. In our previous discussions, we had already seen the even harmonics will not be existing, or it will get cancelled in the system itself. So the total flux can be written in terms of odd harmonics: phi 1, phi 3, phi 5, phi 7, etc. And it is written phi is equal to phi 1 plus phi 3 minus phi 5 plus phi 7. It is written as minus phi 5. It is because the fifth harmonics will be having an opposing nature, and all the triplet harmonics will be getting cancelled or will be getting neutralized, since it is a three-phase system. So we can again write the total flux phi is equal to phi 1 minus phi 5 plus phi 7. The rest of the harmonics can be neglected because the magnitude will be very less. The harmonic contents in the flux waveform also will be producing some induced voltage in the rotor, and corresponding to that there will be the current and will produce the harmonic torques too. The order of the harmonics can be given as 6 am plus or minus 1, where a is a positive integer and m is number of slots per pole per phase. And the synchronous speed corresponding to the nth harmonic can be written as 1 by n times that of the synchronous speed, or 1 by n into ns. If we analyze the system, we can understand the nth harmonic, which is having an equation 6 am plus 1, will be rotating in the same direction as that of the fundamental, and a harmonic which is having the order n is equal to 6 am minus 1 will be rotating in the opposite direction. That is why when we are writing the flux equation phi, we are considering it as minus phi 5 and plus phi 7. And there we have considered a is equal to 1 and m equal to 1. We get n is equal to 7 and n is equal to 5. So the seventh harmonic will be rotating in the same direction as that of the fundamental frequency component or flux, and the fifth harmonics of the flux will be rotating in opposite direction as that of the fundamental frequency flux. And for seventh harmonics, the speed will be ns divided by 7, and for fifth it will be ns divided by 5. When it rotates in opposite direction, it will be producing a braking torque because the direction of rotation of the flux is in opposite direction. An analysis of the odd harmonics is given in the table. Phi1 is the fundamental component, Phi3 and Phi9 are odd harmonics, and we have Phi5 and Phi7. Phi5 will be having an opposite direction and results in braking torque, and Phi7 in the same direction and will be the normal torque that is produced in addition to the fundamental frequency component. Now we will consider the torque slip characteristics in the case of the induction motor. We will have to consider the torque corresponding to the seventh harmonic as well as the fundamental frequency component. So the total torque will be the sum of the torques that are produced by the fundamental frequency component of the flux and the seventh harmonic content of the flux. The shape of the characteristic is given in the graph, the relation between the torque and the slip, and there again we can see a stable region which will be caused by the seventh harmonic content. If the load on the machine is in that region of stable operation, the machine will be continuing to rotate with a speed ns divided by 7 because it is also a stable region for the machine. This is what is meant by crawling. And since it is a stable region, the machine will continue to run with the same speed. It will not be picking up the actual speed, or it will not be going to a higher speed. We will see the methods by which the crawling can be eliminated. The crawling will be pronounced, but will be more if the rotor slots are less than 1.6 times the stator slots. So we can make the rotor slots greater than 1.6 times that of stator slots. By the method of short coding, the fifth and seventh harmonic in the flux can be reduced. That also will be helping to eliminate the crawling. And the crawling will be less prominent in the case of slip ring induction motor because it is having the high starting torque. So better to go for slip ring induction motor than the squirrel cage induction motor if we need to avoid the crawling effect. Next we have the cogging in the case of induction motor. In the case of squirrel cage induction motor, even if we are providing with a rated voltage, it may not be starting by itself, or it will refuse to start. This phenomenon is called cogging, or it is also called teeth locking. It is because of the magnetic locking that happens between the stator and the rotor. The cogging is caused because of the slot arrangement that is given on the rotor and the stator. We will have to consider the space harmonics on the stator as well as the rotor. The order of the harmonics is given by n is equal to 6 am plus or minus 1, where m is the number of slots per pole per phase and a is a positive integer. And we have the space harmonics on the stator given as n and n dash as the space harmonics on the rotor flux. We will consider the total number of slots on the stator as SS and number of slots on the rotor as SR, and we can rewrite the equation n is equal to 2SS divided by P plus or minus 1 and n dash is equal to 2SR divided by P plus or minus 1. Cogging takes place when the order of harmonics on the stator side and the rotor side are equal, or when they are getting locked each other. So the condition can be written as 2SR divided by P plus or minus 1 equal to 2SS divided by P plus or minus 1. We will consider different cases. In case 1, 2SR divided by P plus 1 equal to 2SS divided by P plus 1 implies SR equal to SS, or 2SR divided by P minus 1 equal to 2SS divided by P minus 1 implies SR equal to SS. That is the condition for case 1. In case 2, we consider 2SR divided by P minus 1 equal to 2SS divided by P plus 1. That implies SR minus SS equal to P. And case 3, we consider 2SR divided by P plus 1 equal to 2SS divided by P minus 1. And there also we get SS minus SR equal to P. From the above 3 cases, we can conclude the number of slots on the rotor and the number of slots on the stator should never be equal. Or we can say the difference in the number of slots on the rotor and the stator should not be equal to P, the number of poles. That is given as modulus of SR minus SS should not be equal to P. And another way of reducing the cogging or to eliminate the cogging effect, we can go for skewing the rotor slots. Hope you remember what is meant by skewing. The slots should never be in parallel to the shaft of the machine. As in the case of crawling, the cogging also will not be prominent in the case of slip ring induction motor because of high starting torque. Hope now you have understood what is meant by crawling and cogging in the case of 3-phase induction motor, and that mainly happens in the case of squirrel cage induction motor. It can be avoided by different means, by the arrangement of the slots and all. And if we select slip ring induction motor, both crawling as well as cogging can be minimized. Thank you.